Good afternoon, ladies and gentlemen. My name is Alexio Picco. I'm the Managing Director of the Circon Group, and I warmly welcome you to the Connecting You Insights 2021 Spring Edition. We are now at the second event of the day. We have just finished the first one, a very nice interview with Jesse Fenstock about the Getting to Zero Coalition. And as a natural link of this first interview, now we have a very, very interesting session of the hot topic by definition now, hydrogen, and specifically hydrogen application for ports and logistics. I always tell the story about hydrogen to the people, they know me, that I remember very well when I used the first hydrogen bus inside the Munich airport. It was 2007, 2008. So that means that technology was already mature in a way, but not everything else. Not really the policy, not really the industry, not really the finance. Now, I think really we are at the turning point. All those elements I have just mentioned, they are now there. And we need to talk about it. We need to understand where we are in terms of application in ports and logistics. And for that, we have invited four excellent speakers in order to treat this subject from different angles, different perspectives. We have first Lionel Boillot, that is project manager of the fuel cell and hydrogen joint undertaking of the European Commission. Grzegorz Pawelec, that is research, innovation and funding manager of the main association about, let's say, Hydrogen Europe. Stéphane Reiche, Délégué général of the Grand Port Maritime de Marseille about hydrogen, and Suvi Kari-Rinne, director of Webic Research Platform, University of Vaasa. So they will give us very different angles, but I hope that you will appreciate all of them. Please, if you want to interact with us, you have the Q&A panel in the system. You can type your questions and we will manage and we will pose and raise those questions to the panelists, and we try to solve as much of your questions if possible. The forum will be recorded and it will be also used in social network later. And now I think it's time to start. So I first kindly ask to come on stage to our first speaker, Lionel Boillot, project manager of the fuel cell and hydrogen joint undertaking of the European Commission. Just a couple of words about you. Good afternoon, Lionel, sorry. He's an engineer. He has been working on interregional cooperation projects in Spain, then on public transport in Ireland also. He has been working for 10 years in the European institution as project manager for innovation and research projects on energy and academic exchanges. Now within the joint undertaking is in charge of large innovation projects for hydrogen and fuel cell in transport application, the full spectrum, cars, buses, trucks, and ships. And specifically for ships, of course, we are now really curious to understand from your perspective, Lionel, when, I mean, or at least what's the perspective? I mean, it's a short term, it's a medium term, it's a long term. So thank you very much again for joining, and Lionel, the floor is yours.
Thank you very much, Alexio. I'm sharing the presentation. Do you see the presentation first?
Yes, you can put in presentation mode and perfect. Thank you very much.
Okay, so indeed, I'm project manager at the Fuel Cells and Hydrogen Joint Undertaking, which is a public-private partnership for research and innovation project in the field of fuel cells and hydrogen. So we cover the broad usage of the hydrogen, but as well as the production, the distribution, the storage, and its application in transport. So cars, buses, trucks, and including ships. And in the past 10 years, we have been supporting 285 projects for a total funding amount of 1 billion euro. Before I jump into the details of my slide, ports are under pressure to decarbonize their operation. And there are various forums, for example, the World Port Sustainability Program. And here in Europe, ESPO is ranking every year, sending a questionnaire to the port, what are the main items for their priority work, if you want. So air quality, energy consumption, and climate change are the things ports are developing and putting full speed efforts onto. So my presentation is divided in 4 parts, which correspond to the 4 functions of port. First one, it will be about ships. Then I'll be talking about container handling and port operation. Then about the industry located in port area. And finally, about integration of renewable electricity for hydrogen production and logistics, considering ports as coastal hubs. Let's go into ships. So since 2017, the FCA-JU has been supporting research and innovation projects in the field of ships, looking at different types of fuel cells and different fuels, be it compressed hydrogen, liquid hydrogen, or even ammonia. And what is striking is to see that in a 4-year time, the power of these vessels using fuel cells has been multiplied by 20 times, from 160 kilowatt up to 3 megawatts now. So the ships are of different nature, different power, different autonomy, and all these could be equipped with fuel cells. But what you have to know is that for ships, there is today no regulation on the use of hydrogen as a marine fuel. Therefore, they need to go through a specific approval system. This is why we are supporting projects looking at research at, regulation, code, and standards, pre-normative research, so that we could gain, let's say, a basis knowledge that could be shared, let's say, free of charge to anyone who would like to equip ships with fuel cells and hydrogen. I go now into port operation and specifically container handling. Quite a various number of heavy machineries used for container handling, RTG crane, forklift, reach stackers, are being trialed in many ports in Europe and even abroad. For example, Gossin is producing yard tractor, Terberg is producing reach stacker using hydrogen and fuel cells being trialed at the port of Rotterdam. All these equipment can be equipped with hydrogen and fuel cells. And in fact, the benefits for container terminal operators are clear vis-a-vis the battery. The battery cannot last for the entire shift of 16 hours, more or less, on zero emission. Then you have the fleet of ships and boats used at the port, be it tugboats or pilot boats. And for example, CMB, Compagnie Maritime Belge, is developing a tugboat for the port of Antwerp using hydrogen in a blend in an internal combustion engine. And lastly, to decarbonize the operation of the port, this is when you have the ship at the pier, which needs supply power to supply, yes, the electricity for onboard equipment. It's called the cold ironing or the onshore power. And there we do have stationary fuel cells that can provide this power to the ships while they are at the berth. And just to give you an example, the other day I was reading that a large cruise ship in the port of Barcelona on, let's say, cold ironing or using hotel loads for 10 hours, it's equivalent to the emissions from 300 cars working the full year around Barcelona, 365 days. Specifically from the FCH, we've been supporting the project H2 Ports that will develop a reach stacker, a yard tractor, and a mobile refueling stations in 2 container terminals of the port of Valencia from September this year. Quickly, at the other side of the Atlantic in the US, they do quite a lot regarding decarbonization of the container handling on the trucks themselves. Why? Because the American road network is quite developed, so they look a lot more about the trucks. Now I go into the industry located in the port. You have to know that today 80% of the world consumption of hydrogen is due to the production of fuel. So for refining industries, as well for steel making, for ammonia and methanol production. And all these industries, you will find them in industrial areas of Europe, meaning the Ruhr area in Germany. And in the map on the left, you will see clearly the Rhine river, with the red dots being places where hydrogen is produced. You have the Elbe area as well, and a bit the Donau. And likewise, on the map on the right, which is the hydrogen backbone, well, the earlier version, it has been expanded now, but still the orange stars are where the coastal refineries with a lot of capacity, 5 million tons per year, are located, and you'll see they are on these hydrogen backbones. There are a lot of hydrogen being distributed there. So ports are the key, either at the start or end point for the usage of hydrogen as a commodity or a feedstock. This slide is taken from a press release that I have collected from July to December 2019, looking at the announcements that ports in the North Sea were making regarding green hydrogen. And you could see that Hamburg, Groningen, Amsterdam, Rotterdam, and so on, all had electrolyzer projects at scale of 100 megawatts, 250 megawatts, so that to replace the existing gray hydrogen by green hydrogen. And this will have a lot of benefits regarding the emissions, CO2 emissions in this area. A bit larger now, in the global scale, we need to start thinking about establishing hydrogen trading routes, because some continents will be net importer of hydrogen and some others net exporter. And especially if you look at the US, Europe, Japan, all these three will have to import hydrogen coming from other areas. Could be done via pipeline, but it could be done as well via ships, either as hydrogen or as a hydrogen carrier, like ammonia, for example. The last part, integration of renewable energy to produce green hydrogen. So there are a lot of wind farms located offshore in the seas. And what we have to know is the electricity grid must always be in balance. So the production must equal the demand at any time. Otherwise, the wind farms are shut down to avoid a blackout. So now let's think about some good ideas in order to repurpose the oil platforms that are in the North Sea, equip them with electrolyzer, and use, whenever it's possible, the electricity which is not injected into the electricity grid. That will open up for massive production of hydrogen. It's one setup that has been applied in one of the FCH projects called Big Hit, north of Scotland in the Orkney Islands, where the small island has the capacity to produce 120% of its annual electricity demand. Therefore, they shut down the wind farms. So in order to avoid this, they have put electrolyzers, and with the hydrogen, they can supply electricity and heat for all the harbor offices and the marina, as well for schools. They have developed a hydrogen refueling station that refuel a small fleet of 10 vehicles. And this hydrogen will later be used for 2 ro-ro ferries, one using hydrogen in a blend in an internal combustion engine, and the other in a fuel cell, project called HyC3. In conclusion, hydrogen, green hydrogen, can decarbonize the entire port ecosystem, be it the port operations themselves or considering the port as a coastal hub. So for the clean port operation, specifically to address the container terminal operation with the heavy machineries and even trucks if you want. For the fleets of ships into the port, tugboat, pilot boat, and so on. The cold ironing with onshore power. And for port as coastal hub, then it helps to change or supply even more green hydrogen to the energy-intensive industry, steel, chemicals, and so on, to integrate the renewable electricity from the offshore wind, to start the international trading routes for hydrogen, and to increase the intermodality aspect of the port, being the interface between sea and the inland. Thank you very much for your invitation, and I'll look forward to your question at the end.
Thank you very much, Lionel. It was quite comprehensive. It was a perfect picture of how to bring together the different sides, the port side, how it is related to the industry also. This is a key point, because whenever we discuss with ports, there is always this key point, you know, which kind of industrial symbiosis I could achieve, you know, in my macro region. And I think this is one of the most interesting in a way, and challenging on the other way, part of this, and the same together on how we could use offshore wind energy also, you know, to produce hydrogen. So thank you very much. It was really, really clear and quite much appreciated. Let's see some questions later. So let's go now to the second one. I kindly ask to our second speaker, Grzegorz Pawelec, Research, Innovation and Funding Manager of Hydrogen Europe. Good afternoon, Grzegorz. Grzegorz has joined Hydrogen Europe in May 2019 as a Research, Innovation and Funding Manager, where he's developing the intelligence service, coordinates the funding and financing working group. We focus on future public and private partnership on hydrogen under the Horizon Europe framework, and also the innovation fund. That is one of the key points that we should discuss even a little bit later, that because it's, maritime transport is not that much now influenced by that. Grzegorz is also involved in the Maritime Working Group, which focuses on hydrogen's role in the decarbonization of shipping. So again, thank you for joining. Grzegorz, the floor is yours.
Yes, thank you very much for this kind introduction. Thank you for inviting me. I'll share my screen. I hope you can see it.
Yes.
And indeed, I will talk today about the use of hydrogen technology in the maritime industry, so focusing very much on the first part of Lionel's presentation. Just a couple of words about who I represent. You already mentioned that Hydrogen Europe is a hydrogen association. We currently have around 270 members representing the whole value chain. But that's not the key issue. The key issue is that we are not just any hydrogen association. We are focusing only on clean hydrogen solutions, so to use hydrogen as a way to decarbonize society. And of course, the maritime sector is a part of that. But what's also important is that we are also, and what sets us apart from maybe just an average association, is that together with the Commission and the Hydrogen Europe Research, we are partners and forming this fuel cell and hydrogen joint undertaking, which Lionel has just described. And I won't go into details about what the joint undertaking is doing, because Lionel covered that pretty well. But what's important is that this has, let's say, a role to play in the scope of the analysis that we did. So because this analysis was supposed to inform the research and innovation agenda of the next partnership, the successor of the FCJU, we obviously did not cover fuels like biofuels or batteries, and that's not to say those have no place in decarbonization of the maritime sector, but those were outside of the scope of the analysis. So I will only talk about hydrogen-based option, but this is a thing to remember, that there are actually many other options as well. And what exactly have we covered in our analysis is that, as I mentioned, hydrogen-based option, and out of that, what you can do is clearly you can use hydrogen directly as a fuel in a fuel cell or a combustion engine. You can store it either compressed or liquefied on board of a ship, but then you can also, for example, use a liquid organic hydrogen carrier as a storage way for hydrogen. But you can also produce a number of synthetic fuels out of this renewable hydrogen. So combining hydrogen with nitrogen, you can get clean ammonia. And obviously, combining hydrogen with CO2, you can get a various numbers of different synthetic fuels. And assuming the CO2 source is a sustainable one, then those are perfectly fine options to decarbonize shipping. And then, of course, there's this last step where you have an energy converter that can be an internal combustion engine, whether using 100% hydrogen or some blends with marine fuel oils. Or you can use a fuel cell to convert it back into energy. And those can be either low temperature fuel cell or high temperature fuel cell for various applications. But clearly, you can see on this graph that if you try to combine all those possible options, you get a very big number of possible permutations and possibilities. And this actually is becoming a bit of a problem and a challenge, which holds up development of hydrogen in the maritime sector, because of the fact that there are just so many options. It's actually holding back investments by ports. It's holding back investment by ship owners, which, taking into account that the ships are in operation for 20 or even more years, are a bit reluctant to invest in an asset that they have no certainty that they will be able to refuel in 10 or 15 years time, and that's understandable. So to tackle this uncertainty a bit, that's why we in a way did the whole analysis. Obviously, the first part which we looked at is the cost of fuel production, obviously. And here we arrived, we derived a couple of interesting conclusions. Some of them are, let's say, no-brainers, as you can see, that, for example, all of those options are more expensive than the current fuels. And in some cases, it's 6-7 times more expensive fuel than the existing marine gas oil. To be expected, probably, but this is something to keep in mind. The other conclusion is that, and this is really a no-brainer, is that pure hydrogen options like compressed hydrogen or liquid hydrogen or LOHC are always cheaper than the synthetic fuels option. And that's a simple result of the fact that you just simply don't have to go through these additional steps of synthesis, capturing ammonia, capturing CO2, synthesis, and maybe in case of synthetic LNG also have to liquefy it at the end. So there are additional steps along the way, which obviously add up to the total cost of the fuel. And the hydrogen that goes into those fuels in every case costs the same. So it's to be expected that the more additional steps you need to go through, the more expensive the fuel. And that's the case. So this kind of ranking of various options is also always true, regardless of the fact of what your expectations are regarding future development of renewable electricity prices. Whether you think those renewable electricity prices will fall down in the coming years or rather not, this conclusion will always be true, that the pure hydrogen options will always be a bit cheaper than the synthetic fuels. And what's also good to mention is, out of the group of synthetic fuels, ammonia is always also the cheapest one, because for that particular synthetic fuel, you don't have this additional cost of carbon capture that inflates the cost of the other options. But there's, of course, another way to look at this. This is let's say the impact those various alternative fuels have on the storage capacity on board of a ship. And here, when you look at the volumetric energy density, which is the most important one from the point of view of ship owners, here the ranking of those fuels is almost exact opposite of the, let's say, cost of production of those fuels. So here, those that were the cheapest have the lowest energy density, meaning the cheapest fuels will take the most space on board of a ship. And that has of course huge implications for the ship owners. Also, what's important to know that we all not only looked at just volumetric density, but also took into account in the end also the additional space required for the fuel storage system. So if some options require additional, for example, ammonia would need to be cracked in order to be passed on to a low temperature fuel cell. It also takes some additional space. So it's actually more to that than just looking at the volumetric density of the fuel itself, but still this is a key consideration. But what important to know is that this not only impacts on the cost of the fuel storage system, but this has huge impact on the revenue generation capacity of those ships. So, for example, if you put a compressed hydrogen, for example, on a cruise ship, it's possible that you can lose up to 50% of the total capacity of the ship, so the number of passengers that you would be able to take on board, and this is clearly unsustainable for any ship owner. But here's the thing: while the ranking of those various options remains the same for every single ship type, so compressed hydrogen is always the most expensive one, both in terms of the cost of the system and also the impact on the payload capacity of the ship. When you look at various ship types, you clearly see that while the ranking, as I mentioned, is always the same, for certain ship types, this has a huge impact, but for others, it has less of an impact, which is also rather obvious that if you can refuel a ship very often, or if the payload that you carry is maybe not as valuable as in some other cases, then if you lose a part of this, let's say, storage capacity of a ship, the impact might be much less felt in the loss of revenues. So again, the ranking of those options is always the same. So the cheapest fuel is always, let's say, the most expensive in terms of storage, but for some ships, the impact of that fact is much more manageable. And then the last part of what we looked at is obviously the conversion of the fuel into energy. And here I don't want to go into details, but I would just like to point out on one specific, let's say, difference between using combustion engine, which are currently the prevailing energy source on board of ships, and replacing that with a fuel cell. And the fact that we want to point out is that fuel cells have a specific, let's say, power to efficiency curve, while for combustion engine, you get the optimal efficiency at around 80% of load. But then if you reduce that load, this efficiency drops significantly. In terms of, in case of fuel cells, it's actually not the case. You can run a fuel cell in even up to 20% of partial load, and the efficiency is not only does not drop, but that partial load can be even higher than at full load. And this is quite an important part because, well, as you might know, it's usually the case when you look at average power utilization of ships that on average they indeed operate at partial loads. Some of it might be, of course, connected to the slow steaming application that kind of require the existing ships to not use the power completely, but still that's an important consideration. And then combining everything together, you get clearly to this kind of interesting dynamic that I've mentioned, that as you go from the lower density fuels to the higher density fuels, the cost of fuel increases. So the more energy dense always costs more than the less energy dense one. But of course, you get less of an impact in terms of storage capacity on the ship. And we kind of put this analysis for around 60 different ship types. And this is what we got at the result, looking at which of those analyzed option is the most optimal from cost point of view. And by cost, I mean both actual cost and lost revenue because of the increased storage capacity that you need for the fuel. And the results are that there is a portion of the market which is this really short shipping applications where even compressed hydrogen is the cheapest option. Then you have all the deep sea shipping applications. These are the large container ships, large bulk carriers that go between Europe and China, for example. And for all that market, it's the synthetic fuels that look at the cheapest option. And out of all those synthetic fuels, it's always ammonia that comes up on top as the most cost efficient one. And then for everything in between, it's basically liquid hydrogen. But here's also the thing, this looks like as if the liquid hydrogen would have the biggest share of the market, but if you actually see a number of those ships in operation, what you get is that around 90% of the whole market would be covered by clean ammonia. And then the remaining 10% would be divided between liquid hydrogen and compressed would be only around 1% of the total fuel consumption in the maritime sector today. And the last part that the last issue that we looked at is that how much would it cost from the ship owner's view to switch those fuels in terms of the CO2 abatement, because you know there is a lot of talk about inclusion of the maritime sector in the ETS system, and the result was that the costs are substantial still. So what we see is that depending on the ship type, the costs are from 100 euros per ton of CO2 to around 250 euros per ton of CO, and currently the ETS price is around 40, so less than half of what would be needed in order to make the fuel switch actually financially viable for the ship owners. That's not to say that the ETS is a bad idea for shipping, but this gives you a clear indication that ETS alone will simply not be enough to force or to automatically make the ship owners choose those kind of zero emission fuels over the fossil equivalent. Yeah, and with that, I would like to finish my presentation. Thank you very much, and I'm perfectly happy to answer any questions that may arise later.
Really impressive, Grzegorz. Thank you so much. The analysis is shaping really, you know, a possible way forward in which I was not, you know, so much aware of this. For instance, the big percentage in terms of the global industry, maritime industry, of the possibility for the synthetic fuel, and namely about ammonia. But of course, this is globally in terms of the whole industry. But on the other hand, it's also important, for instance, for all the different policies in Europe, all the short sea shipping connection and related to port, the bunkering capabilities in ports for the short sea shipping connection. So it's important to understand the different dynamics. And it could be also interesting to understand, I mean, how this could be shaped with the existing fuel, specifically with the existing trends of LNG. But okay, this is of course another story where we were focused on hydrogen. So thank you so much, Grzegorz. It was very, very, very interesting. And let's go now to the third speaker. So I kindly ask Stéphane Reiche to join us. Prior to 2017, he worked for Saint-Gobain pipelines in Germany and for Renault in China, so a big industrial background, Stéphane, before being in charge of the Department of Technological and Natural Risk Management at the Regional Directorate for Environment in PACA, Provence and Alpes-Côte d'Azur. He was then head of the Security of Supply Unit and the Directorate General for Energy and Climate, then deputy head of the economic department of the French embassy in Berlin, in charge of transport, energy, and environment from 2014 to 2017. We change now a perspective and we go to a port. So what in this frame that was presented by Lionel and then Grzegorz, the port is already a keynote. I mean, it's more and more a keynote, not only in terms of connectivity, transport connectivity, but also in terms of energy, in a way, connectivity. So it's becoming really a keynote also in the 10E network. Let's see one of the biggest ports in the Med, the approach on hydrogen that started already a number of years ago, and now how things are going on in this frame. So Stéphane, the floor is yours.
Thank you, Alexio. I convert my presentation to a PDF. Otherwise, or did you see the full screen when I just showed it, or? No, we don't see the full screen. Okay. So I'll do it with a PDF. It will inside, be I can tell you as showing the full screen. Okay. So. Okay. So now it should work. So can you see it?
Still not.
No, I think that you have to share your screen. Yes. Okay. Now. Now it should work.
Yes.
Okay. So a green port to develop the blue economy is actually the motto of our strategic plan for the years 2020 to 2024. Hydrogen is a part of this strategy, but let me first, in a few slides, present to you the port. As was said, we are one of the main ports in Europe, especially when we look at in terms of total tonnage. We are actually two ports, two harbors in one. We have the historic eastern harbors in Marseille, which are about 400 hectares, and 50 kilometers away, we have the western harbors in Fos, about 10,000 hectares. That's in this area, in the western harbors of Fos, where we have all the industry, petrochemical complex, steel plants, two actually, one ArcelorMittal and one Asco Metal. It's important to mention because that's one type of consumers of hydrogen, as you all know. The other industrial category, which is very much interested by hydrogen, is refineries, and we have also a lot of refineries on the port area or not far away from the port area. This is to show the kind of traffic which goes through our port. So containers, of course, but also liquid bulk. We had historically 80, almost 90% of our traffic, which was based on oil and oil products. This decreased gradually over the last 15, 20 years for several reasons, among which the closure of refineries in Europe, also a slowdown of the consumption, the fact that more and more oil is refined in oil-producing countries. But in liquid bulk, you also have LNG, as you see here, which is growing. We want to be a LNG hub for not only for importing LNG and inject them into the gas pipelines, but also for the ships which are already coming now for the last 2 years and which have LNG fuel, cruise ships or container ships. The first cruise ships have arrived 2 years ago, and the container ships are arriving this year. Ferry ships are also ordered. The question will be how to decarbonize this LNG on the long term, but that's another story. And so, as I have mentioned, energy transition is actually a phenomenon which has a big impact on our revenues, on our total traffic. So we want to see it as an opportunity. And beyond LNG, we believe very much in hydrogen. And we have developed actually a few years ago a hydrogen vision. A few years ago, it was still 4 dimensions, and we added recently a 5th dimension. So the 4 dimensions were production, import, export, consumption, innovation. These were 4 dimensions we identified when we did like a local workshop back in 2015 to investigate all the opportunities linked to hydrogen. It's not necessarily very, very original having all these categories. Other ports in Europe have communicated also on similar strategies, but it's a way to cover all aspects of the opportunities where hydrogen come in. But it's also a way to describe the specificities of each port ecosystem. For example, in terms of production of hydrogen, before even talking about green hydrogen, the interesting asset we have in Fos is we have Chem1, 2 chemical plants which have about 10,000 tons per year of hydrogen, which is co-produced. And this is quite cheap hydrogen, which is already reused today in some of the applications in the other dimension, in the consumption dimension. I will come back to that earlier. But it's actually a good thing to trigger the hydrogen ecosystem, even if we are also interested, of course, in producing hydrogen with electrolyzers. We have a lot of industrial water, so big water pipelines going to all the plants in the FOS area, which could also deliver a lot of water to the electrolyzers. And we still have land available for hydrogen factories, be they small or bigger. And we have also a lot of land or other types of surfaces or zones which could be mobilized to produce renewable electricity. Over 100 megawatts within the port area, much more if we take into account the floating offshore wind turbines, which will emerge over the next years. If we go over to consumption, the figures here are actually a kind of maximum potential for hydrogen. It's the total movements of trucks, trains, river barges. The warehouses are mentioned because of the forklifts. And Maritime has been mentioned by the two previous speakers. I won't go into details now, but the interesting thing, of course, as was said before, is that we have a kind of synergy which is possible when you produce hydrogen to deliver it not only for mobility, but also for industry and other kind of stationary applications, like cold ironing, where we have an ambitious program of rolling out cold ironing in the next years. We already have for the past 4 years now regular cold ironing functioning on some ferry lines. We want to expand this to all passenger ferry lines in Marseille, but also to cruise and to ship repair activities. Most of this electricity will come from the national electricity grid. Some of it will come also from locally produced electricity, solar panels. We will most probably need also buffering to have flexibility in the system. So fuel cell batteries is one option to create this flexibility, either by having it somewhere to balance the electricity grid, or directly next to the dock to have an electric connection coming from these fuel cell batteries. Then innovation is one important dimension in our port with regard to hydrogen applications. As was said before, the economic model of hydrogen is not completely stabilized today. So there is the need to go through industrial demonstrators. Jupiter 1000 is one of them. I will come back to it in the next slides. And then import-export. At some point in the future, when there will be a lot of hydrogen produced in different countries, there will be a balance which will overlap the national borders. And so we think there is an opportunity to develop hydrogen traffic in Mediterranean, especially through our port. We have a lot of pipelines connecting our port, gas pipelines, which could be converted to hydrogen. We have also, not far away from FOS, existing storage capacities, which today are used for oil products and gas. And today they are building storage capacity dedicated to hydrogen. And so in the next years, we could have also a transport pipeline going from this storage site about 80 kilometers away to our port area. And then the fifth dimension we just added is that we think that on our port, as in a lot of ports, we could have the possibility of building ships, smaller ones or bigger ones, hydrogen equipments. Why not building an electrolyzer plant directly on an industrial port zone or other types of equipments? Services are also very much needed, because as we see, one type of service is the integrator, who can match the kind of people or companies who can match these different dimensions between production, consumption. Of course, the Port Authority wants to do that, but we won't do it alone. This is a timeline where we have tried to explain where we started back in 2015 with this first vision of 4 dimensions of a hydrogen hub, and then a lot of projects which came over the time and which grow in investment in capex, and also in terms of power of the electrolyzers. To name a few of them, not all hydrogen projects appear on this slide. Some of them are still a bit confidential, but it will be an ongoing updating process. Jupiter 1000, there are dedicated slides after that. This called ironing with hydrogen fuel cells also. Here we don't have I don't have a dedicated slide, so maybe I can tell a few words about this. It's actually interesting because it's CMA CGM, which is, as you know, an important shipping liner. With their big container ships, it's too early today to have them use hydrogen as a fuel, but they are, of course, interested in decarbonizing the whole supply chain. And one application is the storage of reefer containers on container terminals, where sometimes the existing electric capacities are not enough, or not always enough when you have seasonal peaks. In some countries, you even don't have any electric network, so you have to use diesel generators. And so in all these cases, it is interesting to study the possibility of using hydrogen fuel cells to have both a greener solution, but also a mobile solution. So you are more flexible in the space you use for storing these reefer containers. You're not stuck with one dedicated zone. You can optimize differently the logistics on the container terminals. Maybe a few words also on Combi Green. It's a demonstrator for pyrogasification. So actually using combustible solide de récupération. So different types of waste to extract gas from them. Among these gases, you will have directly hydrogen. You will have also indirectly hydrogen over methane. I cannot tell the volumes today because it's still confidential, but it's interesting to have this vector for producing hydrogen. Innova, it's a yacht, a hydrogen yacht, which is which is about to be finalized. It will be released next month. It should be, I think, the first hydrogen yacht in the world. Okay, and maybe I go over to the next slides where there is a focus on one of them because the time is running. So this is to go back in time in 2016, where we had described our opportunities of the whole ecosystem, and which then gradually attracted project owners to us. For instance, this one, which I already mentioned, the hydrogen fuel cell batteries for cold ironing. And what is interesting is the kind of circular economy approach within the territory between the two harbors, between the western harbors and the eastern harbors, because we take the hydrogen produced in the Chem 1 plants and then bring them by truck to the port in Marseille for 2 megawatt batteries. Actually, until today, it's only a study which has been conducted, so we know the prices, how many euro by megawatt hour it would cost, what is the gap with the acceptable level by the ship owners. So there's still some way to go. Another project is which I mentioned is Jupiter 1000. So Innovex is a dedicated zone within our port industrial zone where we welcome demonstrators for energy transition. And so Jupiter 1000 is the first of them. Since summer 2019, it's producing green hydrogen through 2 types of electrolyzers. And the next step of this project, which should be operational end of this year, is to get the CO2 from a nearby steel plant, to mix it with the hydrogen and to re-inject then the methane into the national gas pipelines. Another important flagship project is Air Liquide's project to start in less than 1 year the first high pressure hydrogen refueling station for long distance trucks in Europe. At the beginning, it will be only a very modest figure of trucks, about 10 maybe, but it will be there that the technical protocol will be tested before this kind of hydrogen refueling stations can be generalized elsewhere in Europe. For example, in Rotterdam, where there has been also important announcements by Air Liquide for a few years later. Here another project is in partnership with the Compagnie Nationale du Rhône. So also to explain that the way a port authority should look at the hydrogen topic is not only centered on the port zone, but of course connected with its hinterland. For example, with the river connections, there is the opportunity, or we identified the opportunity to connect the hydrogen hub of Fos with the hydrogen hub of Lyon, because they also have an ambitious target for developing hydrogen there in Lyon. And so studies have started to run hydrogen river barges with there is a barge operator which is a partner of this project, which is CFT, Compagnie Fluviale de Transport. We will have to design also the distribution stations in Lyon, in Fos, and maybe also along the way. Okay, and I had a last slide, which is not here, which just to say that all these deployment actions are being evaluated more precisely in partnership with France Hydrogène. France Hydrogène is an association which is fostering hydrogen development in France, and they have started a study with all ports in France to study precisely the potential of consumption and production of hydrogen. And I think this will also give a higher a de-zoom division at a macro level at a national scale. And I hope that at some point we will be able also to connect between all European ports to have this vision at a European level. Thank you very much.
Thank you very much, Stéphane. It's quite impressive the path you started already a number of years ago, and a number of projects running and already done, running and planned. So it's congratulations. It's very impressive. And I took the last point that you mentioned, the fact that ports, as ports, should try to cooperate even more in this respect. That is, in a way, a little bit new. You are quite, as you know, a bit more advanced than others, you know. And I think also you have a very, let's say, relevant role in MedPorts, in the Association for the Mediterranean Ports, but could be the same, trying to, you know, have very nice exchange of views and, you know, exchange of experience between Med and Baltic ports. And by the way, just in brackets, tomorrow we have a very nice interview within the Connecting EU Insights that is Baltic versus Mediterranean. So it will, the two Secretary General, Philippe Guillemé, the Med ports, and Bogdan Oldakowski from Baltic ports, they will, you know, play with this, you know, game, Baltic versus Mediterranean, and hydrogen will be for sure part of this. Thanks a lot. Stéphane, let's go to the last, but of course not least speaker. So I kindly ask Suvi Karirin to join us. Good afternoon, Suvi, and thanks for joining. Suvi has over 20 years experience working both in the university and the business sector as a research and development innovation team, namely in renewable hybrid systems, and degree program leader in energy and environmental technology, as well as a research and development project manager in the industrial production infrastructure development projects in the demanding manufacturing business sector. So also an important industrial background also for you. Most recently, she has worked as division manager in the circular economy business sector. And currently she works as a director of multidisciplinary Vaasa Energy Business Innovation Center, VEBIC, at the University of Vaasa in Finland. That is moving from south to north and a bit already Med versus Baltic. The floor is yours, Suvi, and thanks for joining us.
Oh, thank you, Alexio. So, greetings from the northern part of Europe. So I start to share my screen and my presentation. Okay.
Okay.
Can you see my presentation now?
Yes, perfect.
Okay, thank you. So good afternoon, ladies and gentlemen behind the screens. So it is nice to meet you all. So my name is Suvi Karirin, and I'm the director of Vaasa Energy Business Innovation Center, which is one organization belonging to the University of Vaasa, and I'm also a CHEC coordinator. So CHEC is a project funded by European Union via Horizon 2020 frame program, and the acronym CHEC comes from the words decarbonizing shipping by enabling key technologies in POCs on real vessel concept design. So during this presentation, I'll give you some of the sneak peek to a CHEC project because it will start on June the 1st this year. So like I said, CHEC is a project funded by European Union, Horizon 2020 frame program, and that program aims to combine European research and innovation to achieve excellent science, industrial leadership, and tackling societal challenges. And in CHEC, the consortium set the objectives quite high level to achieve just what was stated in the previous slide. So we want to achieve excellent science, industrial leadership, and tackling societal challenges, because we are proposing to decarbonize long-distance shipping by disrupting the traditional way ships are designed and operated today. So in the project, consortium develops and demonstrates at full scale 2 first-of-a-kind vessel concept design, and those concepts are based on real operational profiles. They are equipped with an interdisciplinary combination of innovative technologies working in symbiosis, and they will reduce greenhouse gas emissions by 99%, achieve at least 50% energy savings, and reduce black carbon emissions by over 95%. So here are Czech partners, and they form a quite impactful and multidisciplinary consortium, combining research and innovation, academia and industry, as well as the global players and SMEs in the field of maritime technologies. So University of Vaasa is the coordinator of the consortium and is also responsible for the laboratory research to the hydrogen engine development. Wärtsilä Marine Power has a strong maritime expertise, especially in the fields of engine propulsion systems, hybrid technology, and integrated powertrain systems. Cargill Ocean Transportation is a leading freight trading business. MSC Cruises is a leading global cruise line business. Lloyd's Register is a global independent risk management and safety assurance organization. And then we have World Maritime University, and they play a significant role in maritime and ocean education, research, capacity building, and economic development. Silverstream Technologies specializes in air application technology. Hasitek Electronics is a market leader in ultrasound-based anti-fouling technology. Delta Marine is a leading ship engineering and design company. Climeon provides technology to convert waste heat to a clean power. And Bar Technologies provides their own wind propulsion system called WindWings. So this is the Czech consortium. So considerations behind the Czech. So over 2/3 of the greenhouse gas emissions from ship sailings to or from Europe or European ports in 2018 came from long distance ships like bulk carriers, container ships, tankers, and passenger vessels. So reliance on heavy fuels and the absence of the viable low carbon alternative fuels has led to a situation where long distance shipping is lagging behind other types of energy intensive industries when it comes to reduction of greenhouse gas emissions. If nothing changes, the IMO expects global shipping emissions to increase by 50 to 250% between 2008 and 2050. So at this moment, there is no this kind of silver bullet technology that single-handedly is able to decarbonize long-distance shipping in the light of these IMO's ambitious 2050 goals. So rather than stacking novel technologies into existing vessel designs, the consortium proposes to develop this unique future-proof vessel design platform. And the approach how we propose to decarbonize long-distance shipping is presented as an interaction of 3 layers, which you can see in the image. We have the first layer is the ship design and integration layer, where a novel vessel design approach called future-proof vessel design platform is realized. Then we have technology development layer, where novel technologies and their interactions for maximal synergies is developed. And then framework conditions layer, where the analysis of the framework conditions to maximize the impact of the innovative technologies to be deployed in real world are realized. So these are the 3 layers that will be worked on in Project Czech. So I mentioned these technological synergies, and here is some image to actually enlighten a bit what we mean. So we have 2 real vessel concept design, Kamsarmax bulkhead concept design, and it will be centered around this fixed wing sail technology. And the Meraviglia class cruise ship concept design, it will be focused on innovative hydrogen engine technology. And you can see those under the same notion of new energy technologies in the image. And these 2 technologies, they form the basis of the 2 vessel design, and they work in symbiosis with other cross-cutting technologies, including additional fuel sources. And as you can see, those other technologies, they are presented as a 3 groups. The blue one is operational technologies and practices. The green one is propulsion/power supply technologies. And the red one is drag reduction technologies. And there you can see the technologies under each category. So the Czech bulk carrier, the combination of technologies to be integrated in this vessel design. Of course, we have the solid wind sail from the New Energy Technologies group. And then from the operational technologies, we have automated vessel routing and sailing. From propulsion and power supply technologies, there is waste heat recovery, hybrid energy, and then we have fuel flexible gas engine and a scalable power plant. And from the drag reduction technologies, gate rudder, hull, form optimization, air lubrication, and ultrasound underfooling are integrated into the design. And how we expect our emissions reduction and because we are aiming to decarbonize long distance shipping, so we have estimated how we actually can achieve that during Czech project. So the emission saving targets show that combination of operational and propulsion and power supply drag reduction technologies, and also the wind sail in the bulk route design, we expect to achieve emission reduction of 40%. And the rest comes from the switching the liquid fuel into LNG, and then gradually increasing the portion of bio-LNG, either bio or synthetic methane in the future. And then we have the Czech cruise ship design. And from the technologies to be integrated in the cruise ship design, we have the novel technology, which is fuel cell compatible hydrogen engine. And then operational and technology, operational technologies and practices. So we have itinerary optimization, propulsion and power supply technologies. There will be waste to power and hybrid energy and waste heat recovery technologies integrated. And from the drag reduction technologies group, gate rudder, hull optimization, air lubrication, and ultrasound underfooling technologies will be integrated into the ship design. And the cruise ship designs emissions saving targets. So combination of this operational propulsion and drag reduction technologies, and they are expected to achieve 50% of emission reduction, and the rest comes from switching the fuel into H2 blend, so hydrogen blend. So start with the 20% hydrogen and then increasing the gradually the portion of hydrogen and doing the development there in the fuel and in the engine. So schedule of Czech. So this is a 3-year project. So the duration is 36 months. It starts in June 2021. And the World Maritime University is responsible all the results, dissemination and exploitation. So we will have our own website. So please come and check us up what we are doing in our mission to decarbonize long distance shipping. So thank you very much for your attention.
Thank you very much, Suvi. It's very interesting, the perspective to mix together also different kind of technologies, not only the alternative fuel but everything else. And this is also it is giving me the chance to explain a little bit one issue that was until a certain point in time, this was focused on the kind of cargo transported by the vessel. We have also another project that is going to be presented this week that is, conceptualizing a feeder vessel, in a new kind of feeder vessel for a very short connection, but where the main focus is how, how to handle the cargo, okay? Where your focus is just globally how to put everything together, especially from the technological point of view. So this is, I think it's very interesting, and we will for sure follow the Czech project with very carefully. So I now kindly ask all the speakers to jump again on stage for, I have a couple of questions to raise to you all, okay? Thanks, Grzegorz, Stéphane, and Lionel. So I divide the two kind of questions. The first one is more for Lionel and Grzegorz, and that is, okay, imagine that you are a port authority, someone that is in charge of the governance of a port community. Which measures, which plan, what's your best option to do now? So you are now try to develop something. Where do you start? I mean, you are a port and you have a clear understanding of what could be the hydrogen framework in the near future. Where is your starting point? Lionel.
Yes. Well, first from the FCSJU, we are about to publish a tender for a study looking exactly at what you indicate, how to help support ports that are interested in hydrogen, have heard about hydrogen, and they don't know from where to start. My 2 cents reply to your question would be, I would focus on gathering the demand. Ports, the full ecosystem. The Port Authority should not think in isolation, but it should be a coalition of actors from the industry, from the transport sector, who will be using that hydrogen to aggregate demand. And then my focus will be on the production of the hydrogen, how to link renewable electricity to the production of the hydrogen. But clearly we do speak a lot about valleys now. Ecosystem cluster for the hydrogen.
Thanks a lot, Lionel. In fact, I was joking with, I don't remember with whom, but I was joking that we need to be careful now, because as soon as you go around the corner, there is now a hydrogen valley that is open, because there is a lot. Okay, some of this is still marketing, but some of this, as we have seen, for instance, in Marseille, is really true. Grzegorz, what's your point of view? Being a port, where is the starting point from you?
Well, I would agree a lot with what Lionel said. So it's a lot about building a local ecosystem, and as Lionel said in his presentation, most of current hydrogen demand is located in and around ports. So there is plenty to build around, both in terms of local consumption. There are port operations that you can do. So there is plenty of actors already there, and ports have a large role to play. One additional point to what Lionel said, what I would say is that obviously the answer to the question will be also a bit different depending on the port operational profile. If it's a container ship, a kind of container port that focus on servicing, a large scale container ships that go extra EU voyages, and then probably synthetic fuels are the option that port should focus on. But if it's a port focusing on, let's say, ferry operations, then I would focus on pure hydrogen options first and foremost, because you can use that perfectly fine if the ships go in line operation between only fixed 2 ports, can be refueled very often. You don't need to go into static fuels there. So the answer also varies a bit depending on the operational profile and let's say business model of that particular port.
Thanks so much. But it's important to notice that you both mentioned the fact that you need to create, the community, the cluster, the environment. This is the key point, specifically because now ports, they are really going outside their transport in nature, in something that is not natural for them. Okay, they were energy consumer, yes, okay, but not an energy player as they could be, and this is totally changing the perspective. And of course it's challenging, it's interesting, I can be enthusiastic being a port, but of course you need to be careful also in the choices, in the strategic choices, having so many alternatives in front. So on the other perspective, I would ask first to Stéphane. You are doing already a number of projects, but look into the European Union, which kind of policies could even support more the development of this alternative fuel? We know that, I mean, the Green Deal is covering more or less everything, but is there anything that is still missing in this global package that is sustainability, Green Deal, and alternative fuel? Is this something missing still?
As I said during my presentation, and as it always appears when you go into the economic model of the hydrogen ecosystem, the business case of hydrogen is not necessarily yet now if there is not any help. So the Green Deal is going into that direction and creating incentives, especially for CapEx. The question is then on the OpEx side, both are linked. When you have a less CapEx, you can through the amortization,
depreciation.
Yes, depreciation. The OpEx will be lower, but the analysis of a lot of industrial companies is to say that only through CapEx subsidies the business case will not emerge. So there is a need also to help on the OpEx side. I'm not completely sure how the Green Deal or the other subsidies will be able to do that. In France, we have adopted in end of last year hydrogen strategy where the incentives will be both on CapEx and OpEx. So that would be my recommendation for maybe for a limited period of time, but to let the chance to have the business case to develop. Thank you.
Thanks a lot. And Suvi, on the research and development perspective, is there any missing point? And this is anyhow a question also to Lionel in a way. Is there any missing point that should be still covered by research in the near future in this framework, or we are sufficiently covered by what is existing?
Well, of course, if we think about the engines, we do need to develop the hydrogen engine. And then if we think about the fuel, of course, if we want to have a fuel, hydrogen as a fuel for this for ships and for the maritime fuel, we actually need it. So we need to make the hydrogen. So we need to have this business case, and it has to be profitable to make that hydrogen, and it has to be somehow realized that whatever the technology is that you made your hydrogen, if it's like electrolysis based, then the electricity needs to be there if you want your hydrogen to be this kind of low carbon hydrogen. So that is what we, of course, are targeting for. I mean, at this point, most of the hydrogen in global scale, it's produced by fossil fuels. And it's something that do we actually want that, because we have to realize that if we want hydrogen as a fuel, it has to be green or low emission hydrogen. And that is really something that is maybe lacking the scale, how we can actually produce low carbon hydrogen.
Thanks a lot, Suvi. Any other remark from you, Grzegorz, Lionel, Stéphane?
Yeah, I mean, I would support Suvi in this regard, that the engine part, so either it's a combustion engine or a fuel cell, this is something that's very much lacking. We have the fuel cells for trucks, we have the small fuel cells in the 1, 2, 3 megawatt range. But when we talk about cruise ships and talk about large containers, we actually need fuel cells in the range of 10, 20, 40 megawatts. And that's something that we do not have. We have some for maybe stationary applications, but not for marine applications. And that's something that needs to be developed from scratch, basically. Okay, maybe not from scratch, because we have the smaller units that can be upscaled, but we are not there yet, and we don't have those yet. And then when you also talk about fuels like ammonia, Whether you want to use it in a fuel cell, then you have the same problem. But even if you would like to burn it in a combustion engine, those engines are also not there yet. So then we have the storage system, of course, for liquid hydrogen and so forth. I mean, when you go to the larger ship, basically there is the whole technology that we need to put on the ship. It still needs to be developed.
Okay, so that makes the let's say the possibility for a real big ship a little bit medium long term than others, but this was in a way already settled.
If I may, just one sentence, but I don't want to be so negative. Also, I mean, recently, a month or two ago, the FDS has announced a project about hydrogen ferry from Oslo to Copenhagen, and it's a 24 megawatt ship. So, I mean, we are not there yet, but it's not also that far away that we cannot start talking about it already.
On my side, sorry, two comments. One about funding from European sources. There was a recent call for a proposal from CEF, Connecting Europe facility, about sustainable ports. It has been totally oversubscribed, more than, I guess it was 18 proposals from ports, all of them including hydrogen. And in each proposal, you need to have replicator ports, 3 or 4 of them. So that gives you an order of magnitude, 18 times 4 ports in Europe interested by hydrogen solution. So it shows you the trends. And the other comment is regarding the hydrogen quality or color, if you want. Is it true that today the production of hydrogen is roughly 60 billion tons of hydrogen per year? Out of that, 95% is from fossil fuel, absolutely clear. In all our projects, at least the one from the FCHJU, the ratio is totally reversed. 95% or close to it of the hydrogen is coming from electrolysis of water by using renewable electricity. And the reason is very simple. When you do put hydrogen cars, hydrogen buses, or hydrogen trains or whatever in your municipality, in your area, in your region, the clear motive at start is to decarbonize operation. So you don't put hydrogen from fossil fuel. Yep.
That's a key point. I think the global impact of policies, industry, and finance now it is supporting this understanding. Now it's day to day. It's more and more clear that hydrogen, but how it is produced. It should be a certain kind of hydrogen from renewables, and that is a step by step that we are closing the loop. So I really thank you, Lionel, Grzegorz, Stéphane, and Suvi very much. It was, for me personally, was very, very, very interesting. I learned a lot from this one. I cannot say that the next time we will be already together on a hydrogen vessel, but at least I hope that the next time we will be together physically in a place, at least, to organize something that we could exchange some views even after, and with some people in front of us that could interact with us differently, because this is what being human being, it's what we also need for the near future. So thank you so much. It was really interesting. Thank for all the participants. We had a lot, and I really support you to follow all the rest of the week. Tomorrow we have at 12 an interesting one on application of 5G in ports. So we go to IT technologies. And then we have also this already mentioned Baltic versus Mediterranean game with the 2 Secretary General tomorrow afternoon at 2 p.m. So thanks a lot, and you will find everything on our social net later on. And thanks again to the organizer and to Hydro News, that was our media partnership. And I hope to see you very soon. Thanks a lot, and have a nice day. Bye bye.
Bye bye.
Thank you.
Bye bye.
Bye bye.
Bye bye.